I want you to take a look at the list of items there. These are reviews of movies made by users who watch this movie. The first one says, I hate this movie. The second one says, movies like this, or this is one of the best movies, or this is one of the best films. And the third one says, movies like this should be rated high. It's very easy as humans for us to figure out which one is a negative comment and which one is a positive comment. For instance, the first one is negative. The second one is positive, and the third one is positive as well. That is easy for humans to do, but for computers, it's a bit difficult, and that is what we are going to be doing today. We are going to be writing the program from beginning to end, step by step, step by step. I'm going to be explaining all the bits and lines of steps we are going to write. Again, the step-by-step procedure, including the source codes, is right here for you to use for free. So in this tutorial, I'm going to explain everything. We are going to be using the source code, and you see how it works. It's fairly easy. So basically what is happening, the first step is to separate this sentence into a list of words, into an array of words. So basically, this sentence here will be separated into the first one, I hate, and we have this, and movie. So it will be separated into array, if we call it array of 4 words, like this. The next thing is, and this will be, this is string, of course, you know, this is a string array. Later, it's going to be separated into an integer array of, maybe let's call it A1, of 4 words as well. So in this case, we are talking about something like, just an example I'm trying to give, we can say this is 2, this is 8, and this is 9, and this is 20. And then this is the next step. And final step is that we are going to now resize it into maybe a 20, 200, depending on the fixed size that is expected by the model. So when you feed in this integer array that has a fixed size into the model will accept it as numeric values and now use it to make predictions. So that's basically how it works. So this array of words, you split the sentence into different words, is called bag of words. In a sentence, you can always form a bag of words and carry that bag and then convert it, assuming it's bag of money, convert it into another currency that is accepted by the model, and that is converting the string from string to numeric, bag of numeric words, numeric strings, numeric values that the model is going to use. That's basically how it works. It's as simple as that. So let's now go to do it practically in .NET. You need to actually install Microsoft Visual Studio 2017. That is what you are going to install, and we are going to cover these topics I listed here. Okay, so there was some disturbance. So we are going to cover these topics I listed here. There are about 9 of them. We are going to obtain the data set. Now the data set I'm going to also show you, I have it in my system. If you look at the description box, you'll find a link to get this data set. Download this data set, download the model as well into your system, and let's get started. So I'm going to get started right now. So let's just create a new solution, a new project in Visual Studio. So I'm going to call it Sentiments Analysis. Now, there's something we are going to do. So let me call it Sentiment Analysis Tutorial. So actually, this tutorial is going to be using 2 things that we get from outside. One of them is the dictionary, because if you are doing sentiment analysis, you need dictionary that is going to be used to check your sentence, to be able to retrieve the corresponding value in numeric form. We also need the model, because in this case, the model is actually built in TensorFlow. So we're actually going to be using TensorFlow model in ML.NET. That's interesting, Microsoft have done. So if you have built a model in TensorFlow in Python, you can actually bring it into ML.NET. Sometimes it's a bit more difficult to use ML.NET in things like this. But if you're already a developer, then ML.NET is for you. No need of going to Python, no need of going to anything. Just follow ML.NET. Microsoft has what it takes to make things a bit easier as time goes on. So the first thing we want to do, let's take out this hello world and okay. So let's follow the step-by-step because right here you have the step-by-step procedure here. So I'm going to simply go down and here says obtain the data set. That's the first step you want to do. So you can just click on it. If you click on it, it's simply going to download the data set to your system. So you can see it says, no, I can't really show you, but okay, yeah, I think I can. So if I move it here, you can see it says open, save, and cancel. So the name of the file is a zip file called sentiment model.zip. I'm going to cancel because I already downloaded this folder to my system. So this zip file contains two things. We have the IMDb word index, like a dictionary that we are going to be using. And so this dictionary maps words to integers, right? So make no mistake about it. Then we also have the saved model because I told you we are going to be borrowing TensorFlow model, already made TensorFlow. We call it pre-trained TensorFlow model from Python, and that is what we are going to be using in this lesson. So then we have variables, some other support files that is needed for this project. So now the next thing is the next thing is download. I've downloaded it. I'm going to show you in my system right now. So in my system we have this file downloaded to my local drive. You can see sentiment model, that's the name of the folder, and inside we have variables, we have word index, and we have saved model.pb. Now, if you look at my website, it tells you what pb is. Pb is the TensorFlow model. Pb stands for protobuf. I really don't know exactly what that is, but that is the name of the extension. So what we are going to do first, we are going to add the ml.ml package, Microsoft.ml package, and also we are going to add Microsoft.ml.tensorflow. But TensorFlow is not built by Microsoft, it's built by Google. But the ability to be able to use different libraries is very good. In case you have something done in one library in another program, you can actually use it right here. So I'm going to right click on the project and I'm gonna go to manage NuGet packages, and I'm going to look for Microsoft.ml. If you are doing ML.NET machine learning in Microsoft Visual Studio, you should be using Microsoft.ml package. So just go to browse. You go to browse, and then you are going to type Microsoft.ml in the search box, and it's going to search it out. Microsoft.ml. I have it right here. It searches it out. Just click on it, and then click on install. When you click on it, yeah, that's it, and just click on install. The latest version as of the time I'm making this video is 1.3.1, and that's maybe your own. Maybe when you are watching this video, it might be 1.5. I don't know, but install the latest one. That is fine. If you want to go with this, my own version, you can drop down on that version and select 1.3.1. But I recommend you go for the latest version. Now, as it's installing, you can look at the output section at the lower. Okay, it says accept. If you look at the lower side, lower left-hand corner, you'll see that installing NuGet package. So that tells you the progress of the installation of this NuGet package, and hopefully it's going to install successfully. And then we are going to look for, yeah, perfectly okay. We are going to now look for Microsoft.ml.tensorflow. I think that is it. Microsoft.ml.tensorflow. Let's see. So get it installed as well. Hopefully it's going to search it out, and we're also going to install it. The first one, install again. So as it's installing, let's go to look at the next thing we are going to do. So those files we downloaded from the online repository, we need to bring it into this solution, into our project. A dictionary, the pre-trained model, the PB file, and this folder containing support files. So just right click while you wait for it to complete installation, because I think we can be doing something else. No, we need to allow it to complete the installation. And it does that in a couple of seconds. Okay, fine. So I'm going to right click and I'm going to go to add, I'm going to create a new folder. So this folder, I'm going to call it data, and I'm going to add, let's right click on this folder and just add existing item, and you are adding existing item. That's what you're going to click. You're going to click and then look for where you place the file you downloaded from the repository. And I have it in my downloads here, and inside sentiment model, and I'm going to click on all files and I'm going to choose the two. Okay, so for me to add this other folder, I need to create another folder, but this time I'm going to create a new folder inside the data folder. So I'm going to call it variables. Okay. So there are some support files we need to also add. Existing item, and just go to variables and add it. One thing about machine learning with .NET is that it's kind of easy to follow. If you get a grip on what is happening, you can easily build anything. The key thing you need to know is something called pipeline. Pipeline is like a neural network made up of layers from input to the output. All right, so we need to add global variables. The first one is the length of the array that the model expects. It expects array of length 600. Then we also need the path to the trained model, the TensorFlow model that we brought in. So I'm going to just click on this. Now I'm going to put this right above the main method. That's where you are going to put this code. So you can see two variables have been created. They are global variables. They'll be used across all the classes that we are going to be creating in this tutorial. Now the path is coming from, I think, system.io. So use show potential fixes and just choose system.io. That is the namespace containing the path namespace. Okay. All right. So how the model works, I already explained it. We take the sentence we have, split it into a bag of words, separate the words one by one, and after that, convert these words into numerical representation using the mapping from the dictionary. And then that gives you an array of maybe 6 or 7 words. Then you resize it into a fixed length array that is expected by the model. Feed it into the model makes prediction and gives us the output. The output is going to be two things. It's going to be either positive or negative. So let me see. Yeah. So, all right. The output is two outputs, is either positive or negative. All right. Okay. So how the model works, I've explained it. Now the classes have to be created. They have to create 4 classes. One, a class to hold the input sentence, a class to hold the array of integers. Because we can also hold a bag of words, but this time let's keep the array of integers. So given the sentence is going to be passed into array of words, and we have a list of integer values corresponding to different words. So we are not keeping the array of words and array of integers. We are just keeping integers. So given the sentence, we are getting a list of integers that map to that sentence. So that's why this class I mentioned here to hold the array of words is not really necessary. Okay, so we need a class to hold the input sentence. We need a class to hold the array of integer values that is the mapping of each of these words. And then we need a fixed length array to hold, resize this array, variable length array of input sentence into a fixed size. It's part of pre-processing and machine learning, as you know. You need to pre-process your input to make them match a particular format of input. In this case, it has to be a fixed length of 600 characters. Now, a class to hold the prediction, that is the output. So at this point, I'm just going to create all these classes. So the first one is a class to hold the original input data. So just right click on the project and just add class. So just say add and choose new class. So this is going to be, I'm going to kind of rush over it because it's something not difficult to do. So I'm going to call it movie review. So movie review is simply the user input review IEW, if I'm not mistaken. And the content of this movie review is gonna be, let me just replace everything here. All right, so the next one is variable length integer values corresponding to this list of words in this input sentence. So I'm going to copy this. I'm going to create the next class. I'm going to call it variable length. So let's go add new class. Let's call it variable length. Okay. So variable length, that is fine. I'm going to just replace this with this, what I copied here. So this, I'm not going to be explaining these very codes because I already explained them, so you already know what they mean. So let's save the time by going a bit fast. So this is now the integer array. Now it's resized, right? So it's resized into the feature length. Yeah, so the feature length in this case is 600. We defined it as a global variable above the main method. So vector type, that is fine. Just get it from system.microsoft.ml.data. That's fine. Okay, I'm saving everything. So let's add the next class. Again, if you have some challenges, let me know. I'm going to help you. So the next class is going to be fixed length. Okay, so yeah. So let's just build it. That is fine. And finally, we need to add the prediction. That is like the output. So I'm going to just copy it as well and paste it right there. Again, so we have to correct this as well. There is a way to correct all the errors at the same time. We put all the namespaces by saying control. I know in Spring Boot we have control O. Yeah, control O. It adds all the namespace. I don't know about Microsoft. If you have idea of how to do it, leave it in the comment box for me below so that I'll be able to figure it out as well. And then finally, we add the last class, which is sentiment prediction. So new class. So this class represents the outputs. It represents the output of the model. When we feed in the sentence, the input into the model, we have this output. So these outputs is going to give us one, the probability of being positive and the probability of being negative. So the one that have the highest probability is a correct one, or is a prediction. All right, perfect. So the next thing we want to do now is to create the context. If you have followed the previous lessons, you know about what a context means. Context is simply an environment for you to work with models, machine learning models. So we are going to do this in the main methods, right? So go back to the main method in the original program and create the context. ML context is equal to new ML context. All right, so ML context is available in Microsoft.ml, and that's fine. Okay. So we now create a dictionary and load the mapping data. So the mapping data that is in a Excel format. Now I'm going to just show you. This is the dictionary we have. We imported from the repository online. I gave you the link in the description box. So we have all the input sentence. Now this is simple. We are keeping it simple. This is not an exhaustive list of all the words and the mappings. This is just for this demo. You can make it up. You can add more words. You can also search online for a word mapping, word to integer value mapping. You can find a more comprehensive one. All right. So now we are going to create a dictionary and then pull this data from the CSV file and put into this dictionary we are creating. So if I'm going to copy and paste, it's going to be clearer. So let me copy and paste. Now, all parts of this code is annotated to make it clear for you to understand. At this point, text loader should be available in, yeah. So permit me to just expand, right? Maximize the window. All right, so see what is happening here. I'm going to shift this backwards a little. Okay, no, I think that's it. So we have ML context the data load from text file, the CSV, it gets it from the model path, wherever it is, and then creates two columns because we are creating a dictionary key value pair. The first key is the integer, the other one is a string, and then you load the dictionary into the dictionary into this data structure we are creating here. That's what is happening. That is what we just did. At the end of the day, we have a lookup map that contains the lookup map, the dictionary. All right, so the next step says we need to write a code to resize the variable length array into fixed length array. So we have, so is this an action? So we have variable length resize to fixed length array. So we are having this mapping that maps from S to F to F. So variable features is equal to S as variable length features. It resizes the array of features into feature length, which is 600, which is what you already have. All right, so that is what we are doing here. We are resizing into an array of length of 600. When we are given a variable length array, resize it to a fixed length array, and the fixed length size is going to be 600. All right, so we are going to do that again inside the main method. So let me see. Yeah, so we have this is the main method. So I'm going to shift this one downwards a bit, and I'm going to just paste this. All right, I'm going to save. Normally, I like to build my project from time to time to make sure everything is fine. So let me just build solution. So look at the output down the lower left corner of the screen. You can see the output right there. Hopefully the build is going to be successful and everything will be fine. Now, the next step is going to be, we are going to load the TensorFlow model from the PB file we have in the folder into the workspace or into a container of this TensorFlow model, a TensorFlow model object created in .NET. We are going to load the TensorFlow model from Python into this TensorFlow model from .NET. Again, the code is annotated, so it's very easy to follow. This code is also a Microsoft website, but it's difficult to follow. Sometimes you can mix up something, and there are some bugs that, depending on which version you downloaded at the point you are watching this video. So this is the clear one, well explained, annotated, and it should be clear to you. All right, so let's do this. We are loading the TensorFlow model at this point, okay? TensorFlow model should be in the namespace Microsoft Microsoft.ml that transforms. So let me just use it. Okay, fine. So now comes, oh, okay. So now this TensorFlow model, we have loaded it, that is fine, but it has certain parameters that we want to see. We want to see, get some few information about this TensorFlow model. And that information includes the schema of this model, the data view, that is the schema, and then the type of data it accepts and the type of data is going to output. So this is just for information purpose. You can actually skip this very line, but for these demo purposes, I'll just do it so that you can see how the model looks like. All right. So this looks like a lot, but it's actually very simple. So all these are just right line, console.write line. I'm going to again maximize the window. So basically, we are simply taking the schema, TensorFlow model get schema, get model schema. That's all, and we write out the schema, the features. The schema, of course, schema contains columns like feature and prediction. Okay, so we simply get these values, the features and the prediction as well. So basically, we give in features like the bag of words in numeric form resized to fixed length, and we are getting the prediction, and is a softmax prediction. Softmax is the activation. I think is the activation function used to build the model in TensorFlow. So you can watch some of my TensorFlow tutorials to know about optimization and activation as well. So we are going to write out the prediction, and then after that we continue, because this is just to tell us how the model looks like. Now the next step is the important one, where we actually build the pipeline. Now if I copy and paste, it's going to become clearer. So I'm going to just copy and paste. So the model is built, or the pipeline, not the model is already built. The pipeline is built by appending a whole lot of things to create the pipeline. So let me just paste this, and then I'm going to maximize the screen so that you see what we are talking about. Now, if I now have tokenized words, okay, we have these tokenized words. You already know what it means. We also have review tests, the input tests. Now I'm going to kind of do something. Now you should not do this, but I'm doing it. So I'm going to just show you that all the append statements, they are things we are using to build the same model. So you can see that this is one big line of statements. The pipeline is one big line of statements whereby we are appending, more like a trailer appended with different wagons along the line. So we have tokenized words. We append the mapped value. This time the lookup, that is the integers we are going to now use. That is what happens in this place. And the first one, we get the tokenized words. This one, we get the review text and tokenize it into the array of words. And the next one, this append here, which actually goes from here to here, we are taking these words and mapping it into integer values. After that, the next thing in the pipeline says resize this array of integers into a fixed length using resize feature action that we displayed before now above. Let me just show you using here. All right. And the next one says we now append the score TensorFlow model and append we append so TensorFlow model has score TensorFlow model to provide the scores for us. And then the final ones copy columns from this is kind of dicey, but let me try to explain it. So when we have this one, we have prediction softmax and we have the features. But now we are copying the prediction. We are copying this time from this. This is the prediction. We are copying it into prediction and leaving the softmax. The prediction softmax. But we are not interested in the features now. We don't want to display the features. We just need the prediction and the score. That's what you have as prediction / softmax. All right, so I'll recommend do this a couple of times. Initially, it's difficult, but do it a couple of times, it becomes clear. The next and final step not the final step, is to create a model. So now this is a dummy model because this model is already existing in TensorFlow. We imported it, but we need to actually create a model as part of the process of building the pipeline in ml.net. So at this point, I'm going to paste this. So create a data view, and then we feed the data view using the pipeline. So this is a standard procedure for building. I'm going to use this for now. So this predict sentiment should be also y. Predict sentiment. Okay, so yeah, so predict, yeah. So this is what we should now copy the last one. Now I'm not going to spend all the time explaining this because it's well explained using annotation or using the comments. So I'm going to just copy it. It should be outside the main method. So yeah, so this predict sentiment. So I'm going to paste it. It's a function that actually makes the actual prediction. Maybe display the output result. Also, so I've copied some text. I'm going to just take it out. Okay, so now we are almost there. So the predict sentiment is a function that takes the ML context and takes the model and then makes prediction. So the first thing is to create a prediction engine, taking the input text. This time we are having the text to be, this is an interesting movie. And then use the prediction engine to predict. And we have a sentiment prediction. And then we display the length, display the prediction, and then use if statement to answer yes or no if it's less than 5, or if it's less than 0.5 or it's greater than 0.5. All right, so I'm going to run it at this point. So let's see what we have. Okay, hopefully I should have saved, but I think it's saved before it runs. So I don't know how long it takes. It takes a few seconds. Okay, so the first thing that happens is you have this black screen displays. So basically, we are not doing training in this model because if we are doing training, it's going to take a longer time for it to display the output. So this has gone behind. Could not find sentiment model. Oh, okay, I missed out one step. So those files I have in my data folder, I need to change the properties of these files. I need to change the properties of these files to the copy to output directory properties of this file. I need to change them to copy if newer. So that's what I missed out. So I'm going to just come to copy to output directory and just say copy if newer. Okay, that is what you should do. It's also in the step-by-step here in the list of steps, but I missed it out for some reason I didn't know. So let's now run it again. Let's see what we have. First, I'm going to save and then let's run again. I'm going to run. And what is going to happen at this point is that it's first going to display the attributes of this model, this TensorFlow model we imported from TensorFlow. Is going to display the metadata, the schema, the columns, and the metadata of this pre-trained model. And we now have to give an input for it to continue execution. Let's see. And it now displays the output for the model that we are working with. Now take note that there is a sentence that we passed in. Could not find. Oh, I think I should continue and handle the section. Okay, so let's see where the problem is coming from. Okay, copy if newer, copy if newer. Okay, so let's first build the solution. So I'm going to first build the solution, build solution, and after building, I'm going to just run it. So one thing about, yeah, one thing you should learn how to do is to be able to debug. When you have problems, learn how to debug. Debugging skills is the main thing in programming. And yeah, let's see. So hopefully it's going to work this time. See? Okay, so let's see. Could not find the sentiment model. Okay. Model part. Okay. Oh, let me see. So this is quite strange. So it seems to me that I should create, not find a sentiment model. So 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 what I should do, I should place everything, I should create another subfolder. Inside the data folder, I should create a subfolder called sentiment model here. So right click and say add new folder and choose sentiment underscore model. Okay. Wait. Model part. Okay. All right. So I think that is what we should do. And then we are going to move this folder into this folder. Yes, move it. Variables. Then we are going to move these ones into this as well. So let's see. Okay, so we need to have this folder called sentiment underscore model inside the data folder. So save everything and just run again. Let's see. So hopefully this time is going to work. I don't expect to see any other error at this point. All right, so let's see. So, so let's see. So it says TensorFlow model, load model. Sentiment underscore model. Okay, so let's stop it. And let's build first. Build, let's. So let's try to rebuild the solution. So I'm going to go for rebuild. Mm-hmm. So I hope this time is going to work. So let me fire it up. So what we'll actually do is to actually remove the data folder and use the sentiments model. So I'm simply going to move the sentiment model folder here. Yes. So at this point, we actually will not need the data folder. I'm going to just delete it. So at this point, I'm just going to run. So hopefully it's going to run this time, and let's see what we have as output. So in this black screen, it's trying to load the model at this time. Remember, the model is quite sizable. Okay. Yeah. So if you can see the screen, you can see name, features, type, system 32, size 600, prediction, softmax, and so on. So enter. So at this point, it's going to tell us what the prediction is given the input text that we have. So is the sentiment positive? It says no. So let's see. So I don't know, but it tells us if the sentiment is positive. So this is something quite strange to me. So at this point, I'm going to stop. Remember to subscribe to my channel. If you've not subscribed to my channel, click on the subscribe button. And also leave me a comment to let me know if this has been informative for you. We'll see you in the next lesson.